Hello everyone, this is Kitish here. In this video, I'm going to go through the Year 9 Atomic Structure End of Topic test. So let's have a look at question number 1. All substances are made up of atoms. Figure 1 represents a beryllium atom. What is the number of protons and the number of neutrons in the beryllium atom? So, how do we find out the number of protons and the number of neutrons from this diagram? See these positive signs, there's 4 of them. Those belong to particles which have a positive charge. Now, so these particles, so if I label them, that's the protons. The crosses are the electrons. This is the number of neutrons, and these lines are the shells. So what's inside the atom is basically, this structure is actually the nucleus. So inside the nucleus you'll find the protons and the neutrons. So the number of protons is this 1, 2, 3, 4 protons, right? And the number of neutrons is 1, 2, 3, 4, 5 neutrons. Figure 2 represents a beryllium atom. What is the relative charge on a beryllium ion? So here you have 4 protons, 4 protons, each of them has 1 positive charge. That means it has 4 positive charges. Now, the electrons have negative charges. There's only 2 electrons here, and there's no electrons in this shell, right? So, 2 electrons with a negative charge. So, if you add these up, you get 2 plus or 2 positive charges. So, it will be 2 plus. Figure 3 shows the arrangement of atoms in the 3 states of matter. What state of matter is represented by state C? So this would be a gas. Now B, this is a solid, and that's a liquid, and this is the gas. The gas, I should represented by state C, that's a gas, yes. What is the name of the process when state B changes into state A? So state B changing into state A, that's basically going backwards. So what do you call when a liquid changes to a solid? So a liquid changing to a solid. When a liquid changes to a solid, we call it freezing. How can state B be changed into state C? So state B is a liquid to a gas. So how can you change a liquid to a gas? By heating. This question is about carbon and gases in the air. Carbon atoms have protons, neutrons, and electrons. Complete the table by writing the relative mass of a neutron and an electron. Now, In the table, they've already said the proton has a mass of 1. Neutrons also has a mass of 1. Electrons, you could say, has a mass of 0. Or you could say it's very small as well. Now, or you could say 1 over 2000. But the best answer is to simply say it's so small that we write it as 0. What is the total number of protons and neutrons in an atom called? Now, when you add up the number of protons and neutrons, you call it the atomic number. Sorry, not the atomic number, the mass number. The atomic number is actually the number of protons. The mass number is the protons plus the neutrons. Now, 1 mole of an atom, you haven't actually learned about moles here, so I'll leave that. C. An atom of carbon has 6 electrons. Which structure, A, B, or C, represents the electronic structure of the carbon atom? Now, if carbon atom has 6 electrons, remember, electrons are the crosses in the shells. So the first shell can have a maximum of 2 electrons. The second shell can have 8 electrons. So out of the 6, 2 goes in the first shell and the other 4 goes in the second shell. So it will be structure C. So the carbon atom is structure C. Carbon reacts with oxygen to produce carbon dioxide, CO2. How many different elements are in one molecule of carbon dioxide? When they say element, they are referring to what are the different elements? We have carbon and the oxygen. So how many different elements? That's 2 different elements. What is the total number of atoms in one molecule of carbon dioxide? Now, carbon dioxide, the symbol they have given, formula is CO2. So that's 1 carbon plus 2 oxygen atoms, which makes it 3 atoms in total. Sometimes carbon reacts with oxygen to produce carbon monoxide, CO. Calculate the relative formula mass of carbon monoxide. So the mass of carbon they have given is 12. So carbon monoxide, the mass of carbon is 12 and the mass of oxygen is 16. So the total mass will be 12 plus the 16. That gives me 28. So we write as 28 grams. Question number 3. A student tested a seawater sample for dissolved solids. Figure 1 shows the apparatus. So X is this structure. 10 centimeter cube of seawater, boiling water here, and a beaker, and the Bunsen burner. What is apparatus X on figure 1? Now they have given 4 different options. I think we didn't actually, we call this an evaporating basin. Some of you actually wrote it down as evaporating basin, so I should have given you a mark. But you can also use something called a watch glass. Right? It's definitely not a boiling tube. Boiling tubes look like a test tube, but it's slightly bigger, right? A condenser looks like, how do I draw it? Basically, it looks like this. Oops. Let me draw the condenser better. Wait. Second. A condenser basically looks like this, and the funnel obviously looks like that, right? Now, you probably haven't seen a condenser in year 9 yet. The student did the test 4 times. The student calculated the mass of solid on apparatus X after heating. The table below shows the student's results. So you have mass of solid in grams. During test 1, it was 0.12, then it's 0.29, 0.14, and then 0.15. Calculate the mean mass of solid. Do not include the anomalous result. What does that mean? It's a result which actually looks wrong. See this test 2. Result for test 2 actually looks wrong. The reason I'm saying that is because test 1, 3, and 4 are very close to each other. The results are very close to each other, except this one seems to be nearly double the amount what you found in test 4. So we are not going to include that. And they're asking you to write the answer in 2 significant figures. So how do you calculate the mean? So you add these 3 values up and then divide it by 3. So 0.12 plus 0.14 plus 0.15, and then you divide all 3 of them by 3. So 0.12 plus 0.14 plus 0.15, that gives me 0.41 as a total, and then if I divide that by 3, that gives me 0.136. Now they want the answer in 2 significant figures, so it will be the 2 numbers after the decimal, but because it's a 6, I'm going to round it off to 0.14 grams. So you get a mark for writing the answer in 2 significant figures, and you get a mark for ignoring that number, and you get a mark for finding out the mean. Hence your 3 marks. The student distilled a sample of seawater in the apparatus shown in figure 2. What change of state is happening at the surface of the seawater in figure 2? So what change of state is happening? So here you got the seawater. When you heat it, the water is boiling. Now the change of state is from liquid to gas, right? Liquid to gas, and you can call it evaporation. Right? Or you can also call it vaporization. Describe how the water in the test tube in figure 2 is different from the seawater. So the water in the test tube over here, how is that different to the seawater? Now the seawater will obviously have salt, but when you heat it, the water evaporates, and then when it's going through when the steam is going through this tube, it's going to change back into just simply water. So how is the water here different? Water in the test tube is pure water, whereas the seawater will have salts. Why does producing drinking water from seawater using distillation cost a lot of money? So here This is one way of producing drinking water from seawater. In a lot of countries where there's no fresh water, they will have to distill water to get the drinking water. So why is it actually going to cost a lot of money? And the reason is heating water requires a lot of energy, right? Because it requires a lot of energy, it's going to cost a lot of money. F. River water is filtered, then sterilized. It's filtered and then sterilized to make drinking water. Why are these two processes done? So why do we actually filter to remove solid particles? Right? Oops. Right. What's happened to my pen? There you go. And sterilizing, why do we actually sterilize? To kill bacteria. Question number 4. This question is about the structure of atoms. Choose words from the list to complete the sentences below. So you have 4 words: electrons, ions, neutrons, and protons. In an atom, the particles with a negative charge are called electrons. Particles in the nucleus with no charge are called neutrons. An atom has no overall charge because it has the same number of electrons and protons. Remember, electrons have a negative charge and protons have a positive charge. So when you have 2 negative and 2 positive, they will cancel off each other. So the overall charge in an atom is 0. 2 isotopes of the element carbon are carbon 12 and carbon 14. Complete the table of information for these 2 isotopes. So you have the atomic number. The atomic number is basically this number. That's why they are both 6 and 6. The mass number is actually this top number, so hence they have 12 here. The mass number for this carbon is 14. Now, remember, the number of neutrons and protons should add up to the mass number. So, in this carbon 12, you have 6 protons and 6 neutrons, so they add up to 12. So, what is the missing number here, which should add up to 14? So, 14 minus 6 gives you 8. So, 8 plus 6 will give you 14. That's the missing number of neutrons. Question 5. Solids, liquids, and gases are 3 different states of matter. Describe the difference between solid and gas states. Now they are not asking about liquids, so there's no point in writing about liquids. So they want to know, describe the difference between the solid and gas states in terms of arrangement and movement of particles. So in terms of arrangement, right? In solids, particles are arranged tightly, right, in a regular pattern. So if you look at the first question where they had given you the this question. So here you can see in a solid, the particles are arranged next to each other tightly in a regular arrangement, neatly. In a liquid, we're not talking about the liquid for the answer, but there's no regular arrangement, and gas, there is no regular arrangement as well, and there's a lot of space in the gas. So for answer, going back, in solids, particles are tightly arranged in a regular pattern, but in a gas, the particles are not arranged and have a lot of space between them. Now, it's 1 mark to say that the particles are arranged tightly in solids, right? And there's a lot of space between the particles. There's another mark. So this question is 4 marks. So we should get 2 marks for talking about the arrangement, right? And the other part is to talk about the movement of the particles. So movement, right? In solids, particles vibrate in fixed positions. In a gas, particles move randomly right? So that'll be 1 mark, the 3rd mark, and the 4th mark there. Next part, the graph shows how temperature varies with time for a substance as it is heated. The graph is not drawn to scale. So you're starting off here, and then as the time actually increases from 0 forward, the temperature is actually going up to about -40, and then the temperature stays the same, and then it starts to increase from there. Now, here they're not talking about water, so they're talking about a substance. They haven't told you what this substance is. Now, explain. So, explain what is happening to the substance in sections A, B, so in this section, and B, C, and in this section here. So, first we need to talk about that section and then explain what's actually happening in that section. What is happening to the substance in AB, right? Substance is changing state from solid to liquid, right? Now that is just one mark to say that it's changing from solid to liquid. This question is actually out of 4 marks, right? So it's out of 4 marks. So you should be getting 2 marks for talking about section AB. So you need to write one more point, right? What is actually happening to the temperature? The temperature is not changing. So we could say, right, at a steady temperature, section BC, right? You can see that in section B to C, the temperature is actually increasing steadily up, right? Starting at -40 to 360 degrees Celsius. So we can say, right, the temperature of the liquid rises from -40 to 360, right? So I'm going to put that in brackets, and we can say, because in the graph the temperature is going up all the way up to 360 and it's remaining the same. So here, this is when it's actually gone from a liquid to a gas. So it's actually evaporating here at this point, right? Right? The temperature of the liquid rises from -40 to 360 until its boiling point. Question number 6. Colors are used to coat some chocolate sweets. So you have the chocolate sweet here, you have the chocolate in the middle and the color coating on the outside. Very similar to M&Ms or Smarties. Not M&Ms, Smarties. Chromatography can be used to compare 3 of the colors used to coat the chocolate sweets. So you have color 1, 2, and 3. So here you got one spot here for color 1. Color 2 has only got also one spot. And color 3 has actually got 2 spots here. What do the results tell you about the 3 colors? Right? Color 1, right? So you can say color 1 and 2 have only one color, or you could say pigment, right? Say color 1 and 2 have only one spot. So or you could say is made of only one color. So for 3 marks, you need to say the next point, color 3, see this spot, these 2 spots are actually at the same level. What this basically tells you is that color 3 is actually a mixture of color 1 and 2. So color 3 is a mixture of colors 1 and 2. That will give you the 3 marks. You get 2 marks to say that color 1 and 2 is only made up of only one color, and color 3, and this third point gives you the third mark. Next question. The diagram shows a chromatogram of a food coloring. So here you have the food coloring, right? And spot C is what they're referring to here, and you've got 3 spots on the solvent front is the point up to which the liquid actually went up the filter paper. How does a chromatogram show that the food coloring is a mixture? How do you know that it has actually, it's a mixture, since it has 3 spots in a vertical line. So remember, when you start off, you would actually put your original dot on the pencil line here, and when you put the pencil dot on the line, and when you put it on the solvent and leave it, that color will simply dissolve and slowly move up in a straight line. And the reason we can say that it's actually a mixture is because they're all on the straight line. Next part. Plan a chromatography experiment to investigate the colors in an ink. Draw a label diagram for the equipment setup. So I'm going to draw the label diagram. You can actually use this to help you to draw that. So you would have a filter paper, right, or the chromatography paper, and then you would draw a line in the pencil, right? Plan a chromatography experiment to investigate the colors in a ink. So in an ink, so you only got one ink, so you're going to put that ink dot on this pencil line, and then you're going to place this chromatography paper or filter paper in a beaker containing water or solvent, and that level should be well below this dot, right? It shouldn't be touching the dot. So let's label it beaker, right? You could say filter paper, right? And ink, and this line, pencil line, and that would be the solvent. That would be the label diagram of this. Now for 6 marks, you should get at least, if you label all of them correct, you will definitely get at least 2 marks for this. So how do you describe this? First of all, you would put a dot in the filter paper, right? You would draw a line in the filter paper and then put a dot of the ink, and then place the filter paper in a beaker containing the solvent, and you will use something to hold up the filter paper so that it actually falls. So now in the class, you would have actually used a flint, wooden splint, and a paper clip like that. So here's how you can write down the answer. Let me make it small. Sorry. So right. 1 second. Right. So first bullet point, draw a line in pencil at the bottom of the chromatography paper. Now we use a filter paper in the classroom. It's usually called a chromatography paper. You can call it a filter paper as well. You'll still get the mark. Put dots of known colors. Right. So if you're trying to compare, then you will have the ink and you can put the known color dots on the side as well. So put dots of known colors and a dot of the ink on a pencil line on the chromatography paper. Place the bottom of the paper in the water, making sure the start line is above the water. Leave the solvent to rise up through the paper. When solvent nears the top, of paper, remove and leave it to dry. Compare position of dots for known colors with those from the ink. That should give you the 6 marks, but remember, you can draw a detailed diagram and you can actually reduce a whole lot of writing here. But make sure that you draw the diagram and write the detailed answer as well, as I've written it here, if you didn't get 6 marks. That brings us to the end of the paper. Thank you for watching. I will see you in the next video.